Hello students, this is Mr. Damiani and we are looking at lesson 12.3 in our chapter 12 workbook. This lesson is going to be located on page 661 in the workbook. The topic for today's lesson is dot plots and frequency tables. So we've been looking a lot at some data over the course of lessons 1 and 2, and now we're going to look at how to get data organized into a table or on a number line like a dot plot. So you've seen some of these questions, specifically the concept of frequency tables. You've seen this on question 20 for our mountain math boards. It helps with histograms and that type of stuff. So actually, I think you've also seen some dot plots as well. So this may be familiar to some of us as we get to work here. The central question for today is how can you use dot plots and frequency tables to display data? So how can you get those to show you some data? So let's go ahead and take a look at the key vocabulary for today's lesson. A dot plot is a number line with marks that show the frequency of data. Well, what is frequency? Frequency is the number of times a data value occurs in a set. So it's the number of times that a piece of data occurs within a set. A dot plot is how you would display that data on an appropriate number line. So without further ado, let's get a move on and unlock the problem here. Please follow along as I read. Hannah is training for a walkathon. The table shows the number of miles she walks each day. She has 1 day left in her training. How many miles is she most likely to walk on the last day? All right, so what do we need to find? Well, we are looking for the value that occurs most. So let's write that in here. The value that occurs most. Also known as the mode, which you'll see later on in chapter 12. Okay, so in order to begin a dot plot, we need to first decide on a number line. We need to find an appropriate scale for our number lines. So we go to our table here and we take a peek at our values, and I notice that I have a smallest value of a 1, highest value of a 9. So I want to make sure that my number line accounts for the numbers from 1 to 9. So we could definitely number this using a 0 to 10 number line. And if you look at the number line down here, you'll notice it is numbered 0 to 10. All right, so that's the first thing that we want to do. Identify an appropriate scale to suit the data that we have. All right, I wouldn't want to number this number line all the way to 20 if my highest value is 9. That doesn't make any sense. So step 2. For each piece of data, plot a dot above the number that corresponds to the number of miles Hannah walked. All right, so let's take a peek at how that works. You'll notice I have a 1. When I go up here, I have a 1, place the dot. How many 2's did I have? There should have been 4 2's. 1, 2, 3, 4. I should have had 3 3's that I plotted. 1, 2, 3. And 4 4's. 1, 2, 3, 4. So you're going to go ahead, pause the video, and fill in the amounts for the 5's, 6's, and 9's. All right, so your values should match mine once you are done filling those in. So I completed the dot plot by making the correct number of dots for those numbers 5 to 10, which were 5, 6, and 9. The number of miles Hannah walked most often is the value with the tallest stack of dots. The tallest stack of dots for the dot plot here would have been at 5 miles. Okay, so if we're answering the question here, the number of miles Hannah is most likely to walk on the last day of her training would be the value that we see occur most often in the set, which would be the 5 miles. All right, perfect. What I would like you to do is follow along while I read the communicate question down here. I'm going to go ahead and extend the page here. It says, explain why a dot plot is useful for solving this problem. So why was a dot plot, like the one you see here, useful for us to determine, or helping us to determine how many miles you would expect her most likely to walk on that last day. So how is that dot plot helpful? So explain why. Go ahead and pause the video, get that explanation written in. Go ahead and take a look at the explanation that I wrote in here. The dot plot was useful because it allowed us to identify the value that occurred the most visually. So you could just see the highest row, and there was your value that occurred most often within that set. All right, so that is what a dot plot is, and I'd like you to go ahead now and turn to page 662 here. We're going to move through another example. We're going to introduce now what a frequency table is. And you're going to see that I'm going to leave some of the frequency table for classwork instead of using that on the video lesson. So let's take a look at our key vocabulary here, something that you would want to include in your summary. A frequency table shows the number of times each data value or range of values occurs. All right. So it's going to tell me how often a number occurs in a set or how often a range of numbers occurs in a set. All right. A relative frequency table shows the percent of time each piece of data or group of data occurs. Relative frequency, I'm going to focus on in class. All right, so Mrs. Dubé and I will hit that during classwork. So our topic right now, we're just going to focus our attention here on frequency tables. So let's go ahead and take a look at the example here. Example 1. Jill kept a record of her workout times. How many of Jill's workouts lasted exactly 90 minutes? So we want to know how many lasted exactly 9 minutes. Now instead of getting in and just trying to pull this from a big table like you have here, there's going to be a way to organize it so it's visually more pleasing and easier to use. So we're going to list the workout times in the first column. So you notice we're dealing with minutes, and frequency is the number of times that amount of minutes occurred. So we have 30, 60, 90, and 120. What we're going to do now is we're going to record the frequency that each time record the frequency of each time in the frequency column. So what you can do here is you can go through and you can count how many 30s you had. 1, 2, 3, 4, 5, 6. And then you're like, oh man, I missed one. So you want to always double check yourself and then find your 7th. All right, take your time. You can also do a tally. So next to the 30 here, I could have done a tally of 7 and then written my 7 down. You'll see tallies used a lot with frequency tables as well. So go ahead and pause the video and fill in your amounts for the remaining minutes of that frequency table. All right, so you'll notice we had 11 60-minute workouts, 4 90 minutes, and 6 for 120. So that is the completed table. Make sure your values match. Now, to answer the question here after we completed the frequency table, we would say, well, how many of Jill's workouts were 90 minutes? And we'll notice that there were 4. So 4 of Jill's workouts lasted exactly 90 minutes. Now, let's bring our attention down here to this relative frequency table. Not because we're going to work through this example, because I told you we're going to hold off on relative frequency until class time, because I feel like that's going to require a little bit more attention. So what I want to fix your attention to is you notice down here in this frequency table, you have what are called intervals. All right, so these are called intervals. Interval represents a range of data, 3 to 7, 8 to 12, 13 to 17, 18 to 22. This is what you've seen on some questions for number 20 on our Mountain Math board. And then you record the frequency of data. So you're looking for how many times a value appears in that range. That's also something you'll see in frequency tables. But this example, question 2 here, is one that we'll probably work within during our class discussion. So we're going to go ahead and jump to the share and show on the next page. Thank you. And what I would like you to do is I'm going to have you go ahead and complete question 1 on your own. You're going to complete the dot plot based on the data to the right. And I want you to answer question 2. So you're going to pause the video, you're going to fill this information in, then you're going to restart, and you're going to see if our answers match up. All right, so go ahead and pause the video, get it done, and get back and join me. Thank you. All right, thanks for pausing that video. Just double check your line plot here for question 1, or your dot plot, also known as a line plot, and see if it matches up here. And always remember too, cross out the values as well. When I did my 3, I could have said, okay, there's a 3, place a dot. Here's an 8, place a dot. Here's an 11, place a dot. 10, place a dot. I could have done that. So that way I just make sure that I account for each piece of data within my set. That stops us from forgetting a piece. Okay. Question 2 here. What was the most common distance Lionel biked? The most common was the tallest point, which was 6 kilometers. And I know that because it was the tallest stack of dots. All right, so let's go ahead. That's your line plot. Let's go ahead down and look at example 3 here. Example 3 says make a frequency table. Use the intervals 1 to 3, 4 to 6, 7 to 9, and 10 to 12 in order to answer the question to get the information into the frequency table. So what I'm going to do is we're going to set up a frequency table. I'm going to do this quickly. So if I definitely jump ahead, I need you to pause it and take your time, get everything filled in the way it needs to be filled in. Okay. Now to save time, you're going to notice that I jumped ahead. So I got this information filled in. I have a title, I have the distance and the frequency. What I'd like you to do is go ahead and pause your video and get this information filled in where I have the intervals recorded from the problem that we're working with. So go ahead and pause the video and get this set up. All right, thanks for taking the time to pause the video. What I'm going to do now is I'm going to go up to the table here and I'm going to count how many numbers fall between 1 and 3. So I'm looking for a 1, 2, and 3. I'm going to erase my old work here. So I'll get that out of there. And I'm going to go ahead and just count how many times I get a number between 1 and 3. 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 numbers that fall between 1 and 3. I'm going to write that in my frequency. Now please go ahead and do the same for 4 to 6, 7 to 9, 10 to 12 by pausing the video, filling in that information, and then rejoin me and I will help you take care of that. Now you notice I've filled in the frequency. So I had 8 values that fell between 1 and 3, 9 that fell between 4 and 6, and that's including the 4 and the 6. 7 to 9 I had 4, and 10 to 12 I had 4. So what we have here is a nice frequency table filled with all the key pieces of information. All right, so just make sure you have what I have for information down. You have a title representing the data. You have your intervals or your values listed. And then you have your frequency column as well. So you have to make sure that you include all these pieces of information when you're organizing your data, because somebody that's not involved in the situation has to be able to look at your frequency table and say, okay, well, what is being measured, daily distance, and how many pieces of those items were, then you got your frequency. So you have to be able to see the details from the data. Now, question 4 is one we can work on within class time. We're talking about that relative frequency. So we're not going to spend time within the video right now. What I want you to be able to come with on your WSQ, all right, hey, you're doing that while you're watching, but let's talk about your SQ. What I need you to be able to tell me here is give me some information on the dot plot, okay? Like, what is it? How do you make one? Then give me some information on a frequency table, okay? And I want to know what is a frequency table and how do you make one? That's what I'm looking for a good summary. And then you can create your question. Remember, the question is, is there something you didn't really understand about what I showed you, what I showed you for displaying the data? Or can you challenge us with a question? Can you see if your group members can answer a question that you wrote about this information using your flip chart? So that's your job, all right? No independent work, but your job is to create a good SQ for that group discussion come class time. All right, so I'd like to say thank you for taking the time to watch the video. I hope you picked up on the information we need, and come to class tomorrow ready to work, and we'll work on some of this after spring break as well. So without further ado, goodbye and have a great night. Bye.